Okay, it's a little bit crooked. There we go. Okay, we're covering 1.1 and 1.2. 1.1. Good morning. Okay, if you have an algebraic expression, an algebraic expression means that it's an expression, not an equation. An equation has an equal sign. Okay. Okay, we have algebraic expressions here that we're going to evaluate or come up with from words. Okay, if you have an expression like 2x and it tells you to evaluate it when x equals 3, what it's telling you is to replace the x with 3. If it's touching, it's multiplied. So 2 times 3, to evaluate that, you get the number 6. Okay, if you have an expression like E over F. If E is 32 and F is 8, you would have E is 32, F is 8. You would have 32 divided by 8, which is 4. So all you have to do is replace the letter with the number. The letter is called a variable, so you replace the variable with the number it represents. Okay, there's quite a few problems here where you have to turn it from words into an expression. Okay, what I want everyone to do, in your book on pages 58 and 59, there's keywords, phrases, and concepts. There's 2 tables there. They're blue tables. They're turquoise, aqua, whatever color you would call that. I want you to put those tables into your portfolio, okay? And that way you'll have it to look back at later while you're doing your homework or whenever. But this is going to be, that's the blue boxes. Put that in your portfolio. That's required. It'll be part of your portfolio grade. Okay, see how it says addition means add or added to, or the sum means addition, those words like that. Most of those you're going to already know, but go ahead and put that table in your portfolio. The one on 59, that needs to be in there too. And the tricky ones, I'll tell you right now, the ones that most people will do backwards and miss are like more than or less than. Those are the 2 that you need to be real careful with. More than and less than. Because normally you just put it in the order the words come. If you said like the difference, you said the difference of a number and 5. Okay. This is a number, this is 5. Difference means, sorry, get it up there where you read it. Difference means subtraction. So you're subtracting a number and 5. You could put any letter for a number. Okay? So you're going to have a number and 5. And the difference of it would be a number minus 5. X minus 5 or n minus 5. You can put any letter. This would be the difference of a number of 5. These 2 are a little trickier because they don't come in the same order as it's written in the phrase. Okay, if it says for less than, if it said 7 less than a number, you don't put 7 minus 7 7 minus x. You don't put that, okay? If you had 7 less than 20, you wouldn't say 7 minus 20. You wouldn't subtract 20 from 7. So you have to have a number and then 7 less. That's one of the tricky ones right there. More than is the same concept. It won't matter like as much in the answer, because when you add a number, you can do it in any order. But more than actually means to add it to the number. If you had 2 more than a number, that means you would have the number and then you would add 2 more to it. In your on your table, it says you can do it this way, or you could put 2 plus x, because it'll work either way. But this is the proper way, actually, that you should normally write it. Just like less than means coming after it. Okay, so we'll do some of the odd ones that are on there, because they're going to be in the back of your book anyway. So we have, how about number 21 says 12 less than a number, less than some number. It's the same as a number. Okay, how would we write that? X minus 12, right. How about x divided by y in words? X divided, bless you. X divided by y, how are we going to do that?
Y divided.
You can write it. You could write it x divided by y, like sideways like that, or you could write it as a fraction, x over y. Either one of those is divided by y. Divided by is also, if it says quotient, if it said the quotient, let me get it up there higher so you can see it better. The quotient of x and y would be the same answer, okay? And does anybody know why this might be important to know how to do this? I guess. No guesses? It's just busy work and we just want to see if you can do it. How about word problems? You have a word problem, you need to be able to translate that into something you can work out. You need to translate it into an expression or an equation. Usually a word problem, you're going to write an equation that you have to solve. But you need to know how to translate it, okay? If you get good at translating word problems, they won't be so bad. Most people look at a word problem and freak out because it's words and you've got to turn it into numbers. Well, this is how to turn it into numbers. Okay? How about if it says a combination? How about if it says 5 less than the product of 2 and a number, 2 and some number, or 2 and a number. Okay, take that just a little piece at a time. Say 5 less than something, you know it's going to end in subtracting 5 from something. So go ahead and put the minus 5, and then you're going to work in front of it. Okay, the product is product, add, subtract, multiply, divide, multiply. It's the answer when you multiply 2 numbers. So you're multiplying something and something. Okay, 2 and a number. So you could put 2 in or 2x, any variable for the number. And if it's multiplied, you don't even have to put a multiply sign. You could just put 2n minus 5. When it's a product that are multiplying, you could just put them touching each other. And the proper normal way to write, you wouldn't write this into. Even if it said the product of a number and 2, you would put it with the number in front of the variable instead of the variable in front. The number in front of the variable is called the coefficient. Here's your variable, that's the coefficient of it. Okay, how about a number times 10 plus 5. How are we going to write that?
X dot 10 plus 5.
X times 10? What did I just tell you about the variable?
10x.
Yeah. It's x times 10, but we're going to turn it around, right? We're going to do 10x because we're going to put the coefficient in front of it and then plus 5. It actually wouldn't be wrong if you put x times 10 plus 5, but we want to put this where it looks normal, the way you're going to be seeing it a lot in the future, okay? So this is going to be how it ends up. How about the sum of 2 times a number, number, and 7. That looks a little confusing, huh? Okay, you're adding this and 7. So kind of figure out what you're doing there before you start writing numbers. Okay, above this, if you want to write 2 times a number, would be 2n or 2x or whatever. So you have the sum of this and 7. So what are we going to do with that?
2x plus 7.
Right, 2x, the sum of this and 7. So we're the sum of this and that. There you go. There's a few problems before that that are word problems, but it gives you the formula, like it may ask to get the area of something, but it gives you the formula. Does anybody have trouble with putting numbers into formulas? Yeah? Why don't we do one of them? Like, there's a triangle. It says to find the area of a triangle. What's the part right here, the dotted line? What part of the triangle is that called?
Height.
The height. That's how high it is. This means it's at a right angle to the base. This is your base right here. Okay, it tells you, like on number 3, it gives you the formula. It says the formula is A equals 1/2 BH. So you're multiplying 1/2 times the base times the height, because they're all touching, they're multiplied. Okay, if you have, it gives you the base and the height. We'll do a different one than this. Let's say the base is 12 and the height is 5. 1/2 base times height. You just plug in your numbers. Base is 12, the height is 5. Okay, 1/2 of something, what you could do is just multiply those two numbers and then divide by 2. If you were doing it on a calculator, which you're not supposed to use yet, you could turn this into 0.5. You could put this as 0.5 and then multiply times 12 and times 5. We're gonna do it this way because we're not supposed to use calculators. That 12 times 5, 60, and then divide that by 2 is 30. I have something missing here. I didn't say what these numbers are in. If these were in meters, you would have, would it be meters here or square meters? Area is always squared. So you had meters times meters. It's squared. So the area, you need to watch and make sure you always have your squared on your units. Volume, if you had like a box and you were figuring the volume of the box. You had volume of the box. The volume of a box is length times width times height. If the length of the box was 10, the width was 2, and the height was 5. You would have 10 times 2 times 5. Does it really matter which order you multiply these in?
No.
No.
Not really. You could do 10 times 10, or you could do 10 times 2 is 20 times 5. You're still going to get 100, right? Let's say these were all in inches. What is our units going to be here? Inches cubed, or cubic inches. Either way, you could say it like inches cubed, or you could say cubic inches. Okay? This one, you could say meters squared. Normally, you just don't say to the second power. You could write it as square meters also. This is more the normal way to do it with the 2 or the 3 up top though. Okay. I think that's enough of a lecture on that. We'll be doing work in class, and if you have questions, I'll answer the questions while you're doing your work. When you look over it, is there any of the problems that look like I definitely need help with that we're just looking at it right away? There's some, like 53 and 54, that have distance. Like it says, has some miles per hour and time. You may need this formula. The distance is the rate times the time. You might need to use that formula. This is your distance, and this is the rate, like miles per hour. And the time would be, if this was miles per hour, the time would be like how many hours? If this was like inches per second, time would be in seconds. Okay, 1.2, talking about the real numbers. Does anybody know what a real number is?
Every number?
All of them?
Whole numbers?
There's whole numbers. Yeah. Actually, it's everything except someday there's going to be imaginary numbers.
0?
Okay? It has all the numbers. It has the fractions. It has the negative numbers, like -1. It even has the square roots, like square root of, even square root of 5, not the perfect square roots, like square root of 4 is 2. But the real numbers is all the numbers except, which they won't be putting it in your book, but it's all the numbers except if there's a negative under your square root. Those are imaginary. So we're going to be talking about all kinds of different numbers. Okay. Let me write a circle and show you how we divide up all the numbers. Here's all of your real numbers. Your negative ones are out here. We'll put them in a cloud because they're imaginary. Okay, we're going to divide this into rational and irrational. Rational, irrational. Does anybody know what irrational is? We have one up there. Irrational will be the square roots that aren't perfect numbers. This is irrational. That would be your square roots over here. Like square root of 5, square root of 7. But square root of 4 is rational. Rational, look at the first part of it right here. It says ratio. Ratio is like a fraction. Rational numbers are numbers that can be made into a ratio. Okay? So you've got your rational numbers could be your whole numbers, like 2, even negative 3. That could be made into a fraction, right? You just put it over 1. Those are rational. See, you have fractions that are rational, but they're not, let's see. There should be some more. Oh, we have integers too. The integers are a part of the rational, but not all rationals are integers. Okay, there's a little section in here, like these are integers. Let's put these are integers, but part of our rational numbers are, let's see, integers are rational, but not all let's put our rationals down here. Sorry. Because, I'm sorry, I'm getting all confused. We have like a fraction, this is rational, this is not rational. Yeah, that is rational. This is an integer, and it's rational. Yeah. Do what? The rationals need to be there. We need our integers as our little separate part, because it can be an integer and it can be rational. We need to put our integers down here that are whole numbers. We need some out here that are fractions, but they're not. Okay, so everything, let's see, rational, we got our integers. I'm sorry, I should have had this drawn up ahead of time. Let me do it here. We have our irrational, our rational. Okay, our fractions, we have some fractions that are rational, but they're not an integer. So out here we have integers, and then we have fractions that are still rational, but they're not an integer, okay? Integers would be the whole numbers, but they're still fractions. Did I just confuse everybody? Yes. Okay. This will not, it actually be something that's on the test. But if you have a number like a whole number, that would be considered an integer, which is all your negative numbers, 0, and all your positive numbers. Okay, those are integers right there. And then you have your natural numbers. They just start at is it 0 or 1? 1. Natural numbers start at 1. 0 is not natural. So there's your natural numbers. Your whole numbers, they start at 0. It's the same numbers as these, except you start at 0. 0, 1, 2, 3. okay, and it keeps going. These don't have any negatives. The integers have all the negatives. Since we're doing real numbers, that includes everything. That includes all the negatives, positives, and the square roots. We'll get rid of that paper. Let's start working with numbers. Okay. And look at the problems you're going to do. Okay, if you're graphing a number on the number line, let's say you're graphing the number -3 on a number line. All you have to do is put a dot where that number shows up on your number line. So -3 would be right here. How about a fraction? How about -3/2? Okay, we don't actually have that number on the number line, but what you need to do is turn this into like a mixed number. This is improper, so what you need to do is do 3 divided by 2 to turn it into a mixed number. 2 goes into 3 one time, 1 left over. This goes on the top, and this number goes on the bottom. So this is the same as -1.5. So where are we going to put this? We're going to put it like about here? Okay. Because this would be 1, and going almost to 2, we're going to put it halfway between the -1 and the -2. That's -1.5. How about a positive 4/5? We're going to go a little past the 1 over here. Somebody say no. It's smaller than 1, right?
Yeah.
Okay, so if you had this divided into 5 sections, it's going to be pretty close to the 1, right? You could visualize, you could divide it into 5, but you don't really have to. Just kind of go over, and it's about right there. Okay? How about if something is greater or less than? Do those signs get you mixed up every once in a while? Not really? There's usually at least one person in a class, and usually more than one, that don't remember which one of these is greater and which one is less. This one is greater, and I'll tell you a way to remember that. This one is less. Okay, think about the numbers like 5 and 3. The 5 is that direction on the number line from the 3. See how the 5, if you were on the number line, the 5, you would go that way from your 3. The 5 is greater than the 3. If you turn this into an arrow, numbers get bigger or greater as you go that way. If you turn this into an arrow, numbers get smaller or less as you go that way. So how about the number -3 and a +3? The -3 on the number line is over here, +3 is here. So -3 is that direction. So if you made it into an arrow, it's less than like that. The negatives are the ones that are a little bit more tricky, because if you had -5 and -3, it's not going to be like this, because the -5 is to the left of your -3. So you need it to go like an arrow to the left. -5 is actually less than -3. Okay, so just visualize the number line when you're doing, comparing numbers like this. How about fractions? Okay, if we're going to compare fractions, how about if you had a negative 1/2 and a negative 1/3? To compare them, you actually need what? Common denominator. If you have a denominator, like you could tell by looking at 2/3 and 1/3, right? You know that 2/3 is bigger than 1/3. Okay, so these have a different denominator. We need to turn them in to fractions that have the same denominator. They're still going to be negatives. Okay, how can we turn this into a number over 6? If you multiply the bottom by 3, multiply the top times 3. Okay, how about this one? 3 times 2. Okay, so now we have negative 3/6 and a negative 2/6. Okay, if that was positive, it'd be real easy. Okay, 2 is that direction from the 1. But think about the negative 3 and the negative 2. You can just kind of ignore the bottoms now. On a negative 3 and a negative 2, which direction do you go? The negative 3 is to the left, right? So this will be to the left or less than.
Isn't it the Pac-Man always eats the bigger number?
It could be a Pac-Man and it could be an alligator. I've heard it as being an alligator too.
That's how I always remember it.
Yeah.
The old Pac-Man always eats the bigger number.
Yeah. Okay, somebody made it into a Pac-Man and he's hungry, so he gobbles up the bigger number. I've seen people turn them into alligators, and the alligator is hungry, so he eats the bigger number too. Yeah, that's another way to remember it. And obviously it helps her, or she wouldn't be thinking that.
Yeah,
That
because I
way.
got cookies and then I drew my Pac-Man.
You drew your Pac-Man and it worked, huh? Yeah, use the Pac-Man too.
Excuse me,
Or the number line. Yes, ma'am.
when we're doing our fractions like that, do we need to write them out? If you do like the 1/2 of time, which one's bigger, 1/2 or 1/3?
Yeah.
We have to like
You
write it out?
probably should, at least, like, when you write the problem down, you could at least do it over here next to it.
And
If
for
you
homework
see that
wise?
you're gonna have to change it, leave yourself lots of room.
Because I think of cookie. A 1/2 cup and 1/3 of a cup, which one's bigger? That's why,
Yeah.
it's like in
So
here.
you already know a half's bigger than a
Yeah,
third.
that's why I was wondering, do I need to write the thing out on our homework?
No, if you already know this is gonna be bigger than that, but then you gotta remember this is a bigger negative than
Negative.
that, right?
Yeah.
Like negative
The
3
negative's gonna
and
make it
negative 2,
smaller.
since it's a bigger negative, it's actually, the bigger negative is actually gonna be less.
Yeah, it's gonna be in opposite direction than
Farther
regular
in the
positive.
hole, yeah. You might have less mistakes if you go ahead and do this, but if you can do it that way, then you just make a mistake every once in a while, you just have to take a lower grade. That's up to you. You don't have to, no. Okay, another thing. If you have, like, if it says that a letter, like X is less than 3, there's another way to write that inequality. Okay, if you want to write it with the 3 in the front, and 3 in X, would 3 be less than X or greater than X? Okay, when you switch sides here, you have to switch the way the direction the sign's going. If you replace a number here with like number 2, 2 is less than 3, you know that 3 is greater than 2, right? That makes sense how you have to switch the sign. Okay, how about if you have, let me get a greater than or equal going. How about if you have negative 2 is less than or equal to y? Write an inequality that's equivalent to that has the same meaning. So we're gonna put the y in the front and the -2 on the other side. So switch the inequality to the other direction. The equal part stays there. I guess you could say you're turning it over, but it stays, if you flip an equal sign, it's still equal, right? It's still a line. So make sure you keep the equal part if you flip it. Okay, how about, is this true? Is -5 greater than -3? This is false. It's less than, right? How about, is -12 less than -13? No, because it's to the, it falls on the other side over here. It's to the right. That's also false. How about, is 4 less than 4? Okay, it's false. How about if you had 4 less than or equal to 4? Because of the equal, that would be true, because it is equal. It's not less, but it is equal. Okay. And we also need to cover absolute value. Absolute value of -8. Does anybody know what that is already? 8. It's 8. How about, what's the absolute value of 8?
-8.
8. It's not the opposite. It's always positive, okay? This is different than defining the opposite of a number, because your answer will always be positive. From what part is inside, the absolute value always turns positive, whether it's positive or not to start with. Okay. So if you have a fraction in here, it's the positive of whatever number that is, right? It's just positive 2 and 4/5. Okay, if you have something inside, like where it says you need to do 8 minus 1, inside here, don't do like, well, absolute value of 8 is 8, and then absolute value of 1. Let's go ahead and just add them. Don't do that. Do what's inside there just like it is. 8 minus 1 is 7, right? Don't split it up and try to make absolute values till it's like totally simplified, okay? So this is the same thing as absolute value of 7, which is just 7, okay? When we get into doing negative numbers, if this came out negative, like if you have -8, and you haven't had to do this yet, so I'm not just showing it to you. -8 plus a -1?
Would be -9.
Okay, that's a -9. And so it would come out to +9, right? But they won't have you do that yet, so don't freak out over it. There is some skills maintenance, and you probably have to do some of it. Here's some percentages that you have to turn to a decimal. That's skills maintenance, because it was stuff that you should remember from last semester. Do you remember how to turn a percent to a decimal?
Yes.
Okay, the easiest one to do to remember is like 1/2 is 50%. If you had 50%, what is that as a decimal?
0.5.
0.5. So what we had to do is move our decimal, right? 1, 2. 2 times. So from a percent to a decimal, that's all you have to do is move your decimal 2 times. If you have 68%, if it starts with a decimal, you need to put the 0 in front. You went 1, 2, so 0.68. 125% is what?
1.25.
1.25, right? How about if you have a fraction going to a percent? Okay, if you have the fraction 1/2, you already know the percent, don't you? You know 1/2 is 50%. How do you get there though?
You divide 1 by 2.
1 divided by 2. And you get the decimal, 0.5. You go 1 divided by 2. 2 won't go into 1. Add a 0, 2 into 10 is 5. So that's how you get the decimal. To get the percent, this, we went back to the left to go from percent to decimal. We're going to go to the right. From this decimal, we go right 2 times. It's always 2, okay? So 2 times, and from here, if you add 2 times, you need to add that 0, so that turns it into your percent. So if you have a fraction like 3/4, turn that into a decimal. 4 won't go into 3, 4 into 30. 7 is 28. Add another 0. 4 into 20 is 5. 3/4 is like 3/4, 75 cents. Some people call 3/4 3/4. That's why. 3/4, 75 cents. Okay, so what percentage is that?
35%.
Yeah, 75%. Move it 2 times, you have 75%. Okay, there's a synthesis on here where you put numbers in order. If you have to put numbers in order and you have fractions, if you can't tell by looking at them like, okay, you know 1/2 is bigger than 1/3. But if there's some you don't know how to do, you can always convert them to decimal and then just put them in order because of the decimal. If you have 1/2 and you have 1/3 and you have 4/5 and you have 7/8, and you need to put those in order. If you don't know by looking at them, turn them all into decimals. 0.5, 1/3 when you divide it, you get a repeating 3, right? And 3, 3, 3. 4/5. Anybody know what that is? Yeah, 0.8. It's the same as 8/10, which is 8/10. Or you could do the 4 divided by 5 thing. 7/8. That's a long one. 7 divided by 8.
0.875.
0.875. Okay? So these are real close to the same number, but this one's going to be bigger, right? Because this would be like 800 if you put some zeros after it. So it's from small to big, you would do your 1/3, your smallest one. Then 0.5 would come next, which is 1/2. The next smallest one is this one, right? 4/5. And then your 7/8. So if you put the numbers in order, it's easier to look at these, to put them in order, than to try to figure out in your head which one is bigger and which one's smaller. And that's all that could possibly be on your homework that I can see right now. Is there any questions from just looking through it? No? Okay. Well, let's start on homework now then.